Hello, everybody. Thank you so much for coming to my session. I do not speak Korean, so I apologize. But if you want to speak in German, French, or English, we can do that. I'm going to speak slower than I normally would. I gave a session at reInvent last year, and the simultaneous translation was not as funny as I hoped. My jokes take time to hit. So I think, is this the last session today? Yes. Okay, so we might go just a tiny little bit over time, but the first thing that I wanted to do was to take a selfie, but we already did that. Did it work, Julio? It didn't reply? Nothing? Okay, so we'll try this one more time. I want to show you a quick demo. If we take a picture and we say at AWS Cloud Ninja, Cloud Ninja. Oh, it's not showing, sorry. Cloud Ninja me, and then we take a selfie. We can try this one more time, sorry. Thank you. And then we tweet, and then we hope that Lambda works. Also Wi-Fi. Hopefully Wi-Fi. And in any moment, ta-da! And that's using a Lambda function. So if we switch back to the presentation here, that's all done using a Lambda function. And I want to show you today that Lambda is able to be used for a lot more than what you think it can be used for. So if you think about the typical use cases for Lambda, it's enforcing compliance or policy engines or web backends. But the only limit to what you can do with Lambda is the code that you can write. And I'm terrible at writing code, and I made that in an hour. So those of you who are far better than me at writing code should be able to do a lot more. So my name is Randall Hunt, and before I worked at Amazon, I worked at SpaceX and NASA, where I launched rockets. And I left a really cool job launching rockets to work in the clouds. So that should tell you how awesome Amazon is. And we are hiring. So if you are interested in working at AWS, there are thousands of open positions, and I would strongly encourage you to apply. My role and Julio's role at AWS is to help developers be successful. And what that means is my contact information is public, and you can reach out to me anytime you want. If you use Twitter and you follow me on Twitter, I'm a bot powered by Lambda. But you can reach out to me with any questions about AWS or even about what you should name your cat, and I will be happy to help you. That's literally my day job. So every day I answer hundreds of emails from developers like you, and we get to build really cool stuff together. And I don't know about you, but that's really fun for me. You guys build a lot of cool stuff. Today I want to talk first of all about what AWS Lambda is. And now that the selfies are over, I'm going to take off my jacket because it's really hot in here. But first I want to talk about what AWS Lambda is. And then we're going to talk about what a serverless application is. And then we're going to talk about the various event sources, the Legos that make up your application are. And then we're going to go over a couple of unexpected Lambda use cases. And then we'll cover some third-party libraries and first-party libraries that have allowed me to be successful with Lambda. So as you saw from Julio's previous talk, JavaScript is wonderful. But secretly it's terrible. So this talk will be entirely in Python, which is a much better language. But no, JavaScript is wonderful, and you can write your Lambda functions in JavaScript, but Python is better, so we're going to do that. So, what is AWS Lambda? Could you please raise your hand if you already use AWS Lambda? So for the purposes of any video that is published after this, that was 100% of the audience. So AWS Lambda is a compute offering from AWS. And if you think about the existing compute offerings from AWS, you have EC2 and ECS, and EC2 provides a level of abstraction at the hardware layer. It says that I don't care about anything on the hardware. ECS says I don't care about anything on the operating system, and Lambda says I just want to get stuff done. And that's a powerful paradigm. It's a powerful abstraction, because if you're a person trying to build something, the code should be the only thing you're concerned about. The business should be the only thing you're concerned about. The operating system, the patching, the layers, Nginx, all of this other stuff, it shouldn't be a thought. It shouldn't be something that gets in the way. So EC2 is, I want to have complete control over everything. ECS is, I want automatic scaling across Docker instances, Docker containers, and all of this other stuff. And Lambda is, I don't care about any of that. I just want stuff to work. So Lambda is this idea of just the code. And if you're going to have this idea of just the code, you have to have a means of invocation. You have to have a means of starting the code. So Lambda responds to events. And there are two types of invocations in Lambda. There is an asynchronous invocation, which says, I don't care about the response to this, also known as JavaScript. And then there's the request response paradigm, which is better, which is, I do care about the response of this, and I want to know what it is. With those two invocations, you can build almost anything. And we have a bunch of different languages that you can build stuff in: Node, Java, Python, C#. You can run anything that really goes down to libc. And you can talk to anything, whether it's within AWS or outside of AWS. The only limit, again, is your creativity. So take the code that you already have, for instance. Has anybody ever written a Rails application? Rails? Ruby on Rails? So you can run that on Lambda. Has anybody ever written a Flask application? You can run that on Lambda. Django, Express. Anything that you think of, it will run on Lambda and API Gateway with minimal changes. And the advantage of this is that you are not paying for idle time. And I'll talk a little bit about that in a moment. But the way that Lambda works is it's charged in gigabyte seconds. Does anybody pay a utility bill? Do you get charged in kilowatt hours? So kilowatt hours are a measure of electricity, and gigabyte seconds are how we measure and bill Lambda. And if you think about a gigabyte second is 128 megabytes of RAM used over 10 seconds, or 1 gigabyte of RAM used over 1 second. And Lambda allows you to bill your compute in that manner. And it's the closest thing to electricity that we can get. Now, Amazon had a terrific opportunity when they were pricing Lambda to make it so that I could make more money. But they did not. They chose instead to make it extremely cheap. Which is why I used it in the first place, but it also makes me a little worried. So, and also, they definitely should have made the price 0.1337 microcents per invocation. That would have been way better. That's a hacker joke, if anybody. Sorry. So when it comes to authoring functions, you have what you see is what you get editor. And what that means is you can write the code right in the console, and I'll demonstrate this in a moment. And you also have third-party plugins. If you write in Java, you can use Eclipse. And if you write in C#, which is even worse, you can use Visual Studio. But if you write Python like a sane and rational human being, then you can use really anything. You can use Notepad, you can use Vim, or if you're a really, strange person, you can use Emacs. And all of the traditional programming models that you're used to, whether they be imperative or asynchronous, they can be used in the same way that you're used to. It's stateless. And when I say that Lambda is stateless, that means that each invocation needs to be idempotent. And I don't know if that word translates well, thanks to the translators there. Idempotency is a concept within computer science that says each subsequent invocation of my program should have an identical result, or a result that does not conflict with the previous result. And that's what you're trying to ensure with your Lambda functions. And then the way that you monitor Lambda functions is through CloudWatch logs and eventually through Amazon X-Ray. So there's lots of really cool stuff coming up at the SF Summit, and I probably just made a huge PR error by mentioning that, but keep it secret. So what are serverless applications then? And serverless applications are basically just Lambda functions that are powering your applications. But before we can talk about what serverless applications are, we have to understand what a server is so that we know how we can take it away. And obviously these functions, they run on servers. It's not like you're completely serverless. But servers means managing OS patches. It means budgeting. It means scaling. It means load balancing. It means all of this other stuff that I, as an engineer, really don't want to do. And even if somebody paid me to do it, I'd probably not do it. And when you take the servers away, so again, owning servers means dealing with operations and management, with scaling, provisioning, to fault tolerance, all of these words that we use at Amazon to describe how you should make highly available systems. This is what a traditional serverless app looks like. So you have your services, your websites, your mobile apps. They go through the internet. They talk to a CDN like CloudFront. And then you can monitor it all with CloudWatch. And then you can have a cache, Elasticache, in front of that. That's typically Memcached. An API gateway goes out and talks to external services, or it talks to other AWS services, or Lambda functions, or even other servers running within your existing infrastructure. That's what a typical serverless app looks like, and it's very, very powerful. You don't have to manage any servers. You don't have to provision anything. It scales infinitely. If I said the number 60 terabits per second, would that mean anything to anybody? So there's a blog post that I would encourage everyone to read where someone was able to get 60 terabits per second of throughput to S3 using AWS Lambda. And 60 terabits per second is enough to download all of the data that humanity created from the beginning of recorded history until 1991. That's when the first social network started. About once a second. So think about that for a moment. That's a ton of throughput, and that's all available with Lambda with no extra effort on your part. And you're never paying for usage when it's idle. And you have availability and fault tolerance built in. And I will say that when it comes to fault tolerance and availability, if we lose an entire region, that's not a great story there for availability and fault tolerance. But I promise we're working on that, and you'll find that it'll get better over time. So the common use cases for these sorts of things are web applications, backends, data processing, chatbots, Alexa, which I was going to demo, but and IT policy engines. So if you saw my talk at reInvent, it was about building a policy and compliance enforcement engine using AWS config rules. So if you are an enterprise and you have to comply with some evil government entity, then you can watch my reInvent talk and you can learn a lot about how to build a policy engine. It's really boring, and we don't want to talk about that. So let's talk about some unexpected adventures and use cases for AWS Lambda. So these are our building blocks, right? We've got S3, we've got Dynamo, we've got services like Recognition. So the selfie app that I just showed you, the Twitter bot, is built entirely on Lambda and AWS Recognition, and it took me about an hour to get it working. And I had never used Recognition before, so that should tell you how easy these services are to use. We have Kinesis and Cognito. We have, for deployment, we have things like CloudFormation, CloudTrail for monitoring, and code commit. These are our building blocks. Okay, these are the Legos that we have to help us make our masterpiece. So you can do just about anything. So the only limit is your creativity. And, sorry.
Hi, Randall. This is Mom. I need to know where you are right away. Thank you.
So, I think we need to code for a second. Sorry. Occasionally, my mother generates a JSON request about what my health and well-being and where I am. For those of you who have spouses or mothers or the equivalent, they generate a lot of requests. Let's call it 10,000 requests per second about your state of health. And I get tired of answering these. I'm one person. I can only answer about 2 requests per second. So when I need to iterate quickly, what I think about is I need to focus on the business logic. I need to reuse functions. I don't need to rewrite functions. And I need to test quickly, locally, and remotely. So I need integration test and unit test to all work seamlessly. And then I need to scale effortlessly. Because if my mother is representative of any mother in the world, 10,000 requests per second is a low estimate. So when it comes to focusing on the business logic, let's think about what this situation looks like. Where am I? So we have the mother, the user, and we have the information. And the mother generates a JSON request to the information data store. And the information data store responds with a JSON response, obviously. Isn't this how you communicate with your parents? And then we have the child uploading information into the data store. Call it a Lambda function. But the child doesn't want to keep updating the Lambda function all the time, so they use something like Foursquare. Is Foursquare used in Korea? No? It's a great app. You guys should check it out. And Foursquare goes and updates the Lambda function, and then we respond. Now, of course, it's not just one response. It's a lot. But it's very easy to do this. So let's think about the code here. This is about 20 lines of code that will generate my current location. Okay? Less than 20 lines of code. I can't count, but let's imagine it's 20 lines of code. And that's all I need to find my current location. And this is the invocation. 3 lines of code. So let's go and look at how all of this functions. Hello? I have to figure out how to turn this one off. There. Can you guys still hear me? Okay. So let's go and look at the code for this. So PyCharm is a really great editor. I use Vim normally, but I've been told that Vim is hard to follow, and Amazon PR has told me that I have to start using something less nerdy. So I should fix this. So you'll find that PyCharm is less nerdy. So we have our Git location, and then we have this API handler, we have an Alexa handler, we have a Lex handler, and we just have these various invocations here. So this is all 77 lines of code, 76 lines of code, and I can invoke it. So I can go to the Lambda function, and I can go test, and it will say, this is my current location, I'm at coex, the timestamp is this. I can update that briefly and just say, where should I say I am that's very bad? Here, we'll go. I'm in the coex Grand Ballroom. So I'll update this and test it again. And now I'm in the coex Grand Ballroom. And I could also go into API Gateway, and I can make a request. And have you guys used API Gateway before? Have you seen this console before? So basically, I have this endpoint, this resource, where I'm making a GET request. It's going through a couple of different transforms. It's going to my integration point, and then it's going through some other transforms, and then it's going back to the client. So then we can, oh, wrong thing, sorry. So then we can curl, and we can get our response. Now, mothers, as many of you know, do not generate one request. So what we need to do is we need to enable caching. And we can enable caching on this by going into the console and we enable the cache. It turns out the cache is already enabled. That's not supposed to be that way, but let's pretend I enabled the cache. Oh, no, it's not already enabled. But now it is enabled. So we save the changes, and now we have a cache. And it's better to return eventually consistent information to your parents anyway. They don't really need to know where you are right now, right? So that's one means of invocation. So has anybody used Lex yet? So Lex is a service for creating chatbots, and it's powered by Lambda functions. So we can take a Lambda function, like this one, and we can go and we can say, and we can return the fact that I was at COEX Grand Ballroom 2 minutes ago. But my mother doesn't use, oh, I was supposed to demonstrate the fact that the caching is working, so. Well, there's still a lot of cache misses. I probably need to publish this again or something. But I don't know how to do that on this tiny resolution, so that's my excuse. But my mom doesn't use Lex. She doesn't use API Gateway. She doesn't really use computers. But she is always, always, always on Facebook. So we can take that Lambda function, the one Lambda function we wrote. Whoops, nope, none of these. And we can say, and we'll get a response. And you guys can go and do this right now. It's just RandallBot2 on Facebook, and you can send a message. And as you can see, I spent a significant amount of time trying to get it to work on KakaoTalk, but it's all in Korean, and it took me some effort. But I did get OAuth working, but I didn't make it past that. So the other thing that we could do is we could try an Alexa skill. And I just want to point out, none of this was working this morning. Like I wrote this code all in the past day or so. So Lambda is very easy to create and deploy and use. It's a little bit better when your functions are all in the right place and you're not having to navigate around and wait for everything. Da, 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 da. And we can ask, and we can listen to the response.
Randall was last at COEX Grand Ballroom 4 minutes ago.
And it's all the same code. It's the same code running everywhere. I'm not, making different invocations and all this other stuff. Like it's just one piece of code that I wrote once. And that's powerful. So that's an application that I built specifically for this conference just to see if it was possible. So I want you guys to think about the things that you've seen so far. We can have numerous triggers. We can have Twitter trigger something. Oh, we even, actually, Julio can confirm this. We were sitting at the hotel bar. We had some soju and some beer before this, like 10 minutes ago. And I wanted to see if Twilio worked. So I created a Twilio integration in Lex, and I said, where is Randall? And I had never done this before. I had never tried using the Twilio integration. I didn't know if it was working or not. And I probably have to be off Wi-Fi for it to work. But we'll see if this works in a second. And I got it working with no effort, which was surprising because typically AWS doesn't get things right the first. Oh, here it went. All through Twilio in Lex. So it's the same code running everywhere. That's a powerful paradigm. And I thought that if I could build these things in a few hours, what could other people do? So I posed this question to Twitter, and in the first 10 minutes, these are the responses that I got. People are using Lambda to cut genomes and do genome processing. They are parsing. So Logstash. Has anybody ever used Logstash? And Elk, the Elasticsearch stack. So if you have a bunch of Logstash nodes and suddenly you have a huge increase in traffic, the logs that you're generating, Logstash takes time to start because it's Java. And it's not an immediate process. So spinning up new Logstash nodes takes time. And this guy on Twitter, he found that it was actually much easier to just direct his logs into Lambda when they were being uploaded into S3 and have that update Elasticsearch and Kibana for him. So he completely got rid of Logstash, which was costing him several $100s a month to run, and instead he put it on Lambda, and his metrics, instead of being 1 hour old, were now 10 seconds old. And in addition to that, it cost him 14 cents a month to run. So hundreds of dollars a month to 14 seconds. And then there's another person who decided that he wanted to let students upload code, and he would run that code in an untrusted environment on AWS Lambda. There was another person who created a bunch of Cloudformation custom resources. And if you guys get my slides later in the speaker notes, I have links to all of these applications. So the Cloudformation custom resources allow you, as part of Cloudformation, to add users into a Cognito user pool. Some person replaced Elastic transcode with an FFmpeg transcoder built on Lambda. All of these are extremely, extremely powerful paradigms. So we're going to kind of speed through the end of the presentation here, but there's a couple of helpful libraries. There's Serverless. That's if you're a JavaScript person, or really anything. But Zappa is one of my favorite libraries. I think Zappa enables people to do magic with AWS Lambda and API Gateway. Complete and total magic. Chalice is another Python wrapper, and it has a couple of differences from Zappa that make it easier to use. Chalice will actually walk through the calls that you're making to AWS infrastructure and custom design an IAM policy with the least privilege based on the calls that you're making in Bodo. Apex is for running serverless applications as well. It can run Go in Lambda. Claudia.js, I have never used it. I don't know anything about it, but it has JS in the name, so it's probably great. Serverless application model is a Cloudformation transform that's open source, so you can go and look at it and contribute to it. And what it does is it makes it much easier to spin up serverless applications without the same extremely verbose Cloudformation templates. It is really hot. And then we have the JavaScript SDK, the Java SDK. The Java SDK, com.amazon AWS serverless, you can install it in Maven or Gradle or whatever. It's very, very powerful. I had never used it before until a few days ago, and I started using it, and it's spectacular. I strongly recommend, and I don't even like Java. And so if I'm saying it's good, you know that it was pretty good. And then we have a bunch of reference architectures. So whatever you're building, there's chances that somebody's built it before. Or if you want to contribute something you've built and add this on GitHub, the Lambda reference architecture repositories in github.com/AWS Labs are very, very powerful. So let's go over a couple final lessons very quickly. First of all, you can invoke Lambdas anytime and anywhere. Second of all, and this is something that's very, very important, and if you take nothing else away from this, the things that allow Amazon to be successful are the ability to work backwards. That's one of our core principles. It's one of our leadership principles at Amazon, is work backwards. And if you start with the outcome that you want and work backwards to the code, I guarantee you will be successful in building the thing you're trying to build. One of the key components of working backwards is the ability to experiment. And in order to experiment, you have to be able to iterate and test quickly. So don't be afraid of writing tests. Use some local testing, so you have things like LocalStack and Modo made by Atlassian, and you have Placebo, which was made by Mitch Garnett, which kind of map out and fake AWS resource calls. You can create a bunch of fake events and fake resources like s3.json and kinesis.json. And then don't be afraid to mix and match languages. if you have a team of people that you're managing, or if you have a team of people working on something, let them work in the language that works best for them to get stuff done. Eventually, you probably want to standardize, but to get started, all you're trying to do is to accomplish a business goal. Make your functions idempotent, reuse functions when possible, and take advantage of the tremendous parallelism of AWS Lambda. If this was interesting to you, Julio and I live stream on Twitch frequently. So I've been live streaming on Twitch since before reInvent, and that's Werner Vogel's. I don't know if you guys know who he is. He's our CTO. He's a big deal. So he like walked up behind us and scared the hell out of me. I thought I was about to be fired, because we didn't exactly get permission to do this. But anyway, Werner Vogel shows up on the live stream sometimes, and maybe he'll sling some code now and then. But typically it's just Julio, myself, and a couple other people, Abby Fuller being one of them, slinging code live on AWS. And I'd strongly encourage you guys to check that out, because you can contribute, you can ask questions live anytime, and we can build whatever you want. And I have my business cards here, and there are more outside. Email me. Thank you so much for listening. Follow me on Twitter. Thank you so much.